Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain. Today we are going to start one of the easiest and the most interesting chapter of class 10th, right? It is a scoring chapter, so please pay your attention. So we are going to start pair of linear equations in two variables. Till now in class 10th you have studied about linear equations, right? Linear equations in two variables, right? What does it mean? That it has got two variables. Let us name those variables as x and y. Okay, you can name those variables as r and t also, right? Whatever alphabet you want to choose, you can choose yourself. So you have to choose two alphabets for two variables. I have chosen x and y. Okay, so and it is linear in nature. What does it mean? That the degree of these variables is going to be 1. Degree of these variables is 1. Okay, what does it mean? That x square, it has got a degree of 2, right? X, it has got degree of 1. So we are talking about this expression here. X and y will have their powers as 1 only, right? So degree of the variable is going to be 1, and there are going to be two variables involved, and there has to be an equation. Okay, let us take an example. If I take 3x plus 4y equal to 7. Okay, now this is an equation because there is an equality sign here, right? And powers of these variables is 1 each, right? So this is a linear equation in two variables, and the variables I have selected are x and y. Okay, but if I take any other power of x or y, let us say 3x cube plus 4y square equal to 8. Now this is not a linear equation, not a linear equation. But some students may say that it has got two variables x and y. It is an equation, so it is an equation in two variables, right? But it is not a linear equation in two variables. For it to be a linear equation, the powers of x and y, or the variables that you choose, should be 1. Okay, there cannot be any other power for x or y. Now other thing that we need to take care, if you need to write the general form here, we can write it like this: ax plus by plus c equals 0, right? Now look at this, it has got power of variables x and y as 1, it meets that criteria. There is an equality sign, so it is definitely an equation. But can we say that it is a linear equation in two variables? We cannot comment on that until and unless we know the value of a and b. What if value of a is 0? If a is 0, then this equation will become by plus c equals to 0. Now is this an equation in two variables? No, because this part has vanished now if a is 0, right? So it is not a linear equation in two variables now. So a cannot be 0. Similarly, we can say b cannot be 0, right? So a and b are non-zero real numbers. Okay. Now how can we write this in one sentence? That a square plus b square is not equal to 0, right? If you write this expression, this means this only. Why? Because if a square plus b square is equal to 0, this can happen if and only if a equal to 0 and b equal to 0, right? These two are, let us say, some real numbers, right? And these are non-negative real numbers, okay, because it is a square. So sum of two non-negative real numbers is 0 only if both of them are 0, right? What I mean is, let us say we have got any number here and any number here, okay, and if it is equal to 0, it can happen only if you have 0 here and 0 here. There is an AND here, right? You don't have any option. If you put anything else here, negative, positive, then this equation will not satisfy. So, if you say a square plus b square is not equal to 0, it will mean that a is not equal to 0 and b is not equal to 0. So, in brief, you can say ax plus by plus c equal to 0, where a square plus b square is not equal to 0 is a linear equation in two variables, right, where a, b and c are real numbers, right. Now, can c be 0? Yes, c can be 0. Even if c is 0, you will still have ax plus by equal to 0. It is still a linear equation. It is still two variable equation, right. So, c can be 0. Even then, it will be a linear equation in two variables, but a and b cannot be 0. Okay. So, this is the first point here. Second thing, let us revise some of the points that we have studied in junior classes. Point number 1 here, let us say you make this x axis and y axis here. This is y dash, this is x dash, right. This is rectangular axis or Cartesian coordinate system, right, where this is x axis, this is y axis, right. Now, this x axis, every point on this x axis, for every point on this x axis, the y coordinate will be equal to 0, right. Let us say this is 1, so the coordinates are 1 0. If this is 2, the coordinates are 2 0. So, every point on this x axis has got y coordinate as 0. So, we also represent this line as y equal to 0. Similarly, this line can be represented as x equal to 0. I hope you know this point. Let us say we move to the next point here. If you have, let us say, one equation only, x plus y equal to 10. This is a linear equation in two variables, right. Now, if I ask you how many solutions can you have for this equation, you will say that if I put x equal to 0, y will be equal to 10. If I put x equal to 1, y will be equal to 9, right. Similarly, you can keep on putting values of x and you will get corresponding values of y. So, how many ways can we find these solutions? So, how many solutions can we find for this one equation? You can put any real number in place of x and you will get a corresponding real number for value of y. So, you can find infinite solutions. This is something that we have studied already, right. We will get infinite solutions for an equation in two variables, right. Now, we have got only one equation here, and graphically how can you represent this? If this is x, this is y, this will be x dash, this will be y dash. Now, for x equal to 0, y is 10, for x equal to 1, y equal to 9. And we also know, let us take it as next point here, then we will come back to this point. Okay. Let us say you have got 2 points in 2-dimensional space. This is the 2-dimensional space where we have got x dimension and y dimension. So, if you have got 2 points in a 2-dimensional space, how many lines can pass through these 2 points? There is one and only one line that can pass through these 2 points, right. So, for a unique line you need only 2 points, right. You can have more than 2 points, that is okay, because on a line you will have infinitely many points, that is okay. But if you are given only 2 points, you can find that unique line, right. there are infinite points on a single line, but out of these infinite points, if you have got only these 2 points, you can still find this line, right? That will be the same line. Now, if you have got x equal to 0, y equal to 10, this is 1 point. So, where is x equal to 0 and y equal to 10? Let us say this is 10. So, this is the point for x equal to 0 and y equal to 10. For x equal to 1, y is 9, right? Let us say this is 9 and this is 1 here. So, where will you find the point 1, 9? This is the point, right? Now, you have got 2 points here. So, you can draw a line, right? Now, this line is for x plus y equal to 10. Okay, that is why we call these equations linear equation, because the graph of these equations is going to be a straight line, right? So, now the graph of this equation I have got as this line, and every point on this line is going to be the solution for this equation. So, that is why infinite number of solutions. But now, let us say you have got 2 lines. How will 2 lines behave? In a 2-dimensional space, if you have got 2 lines, they can cut each other, right? These are known as intersecting lines. They can be parallel to each other. So, these are non-intersecting lines or parallel lines, right? There can be third scenario where these lines are coincidental lines. Let us say these are the 2 lines, right, where these 2 lines overlap each other, right? Let us say this is one line segment, this is another line, right? Now, this line, every point on this line here is also present on this line, right? So, these lines are known as coincident lines, right? Now, from our discussion on a single equation or a single line, right, let us say this was a single line and every point on this line was a solution for this equation. Now, we have got 2 lines, right? Consider this point here. Let us say this point is A comma B, right? Is this a solution for this pair of straight lines? No. Why? Because this is a solution for this line. That is correct, right? But is this also a solution for this line? No, because this point does not lie on this line. So, what is the solution for a pair of lines? The point which lies on both the lines. So, this point lies on this line as well as this line. Hence, in this case of intersecting lines, we have got only one solution, that is this point, right? Now, in this scenario, if a point lies on this line, it cannot lie on this line also, right? Because there is no common point between 2 parallel lines. So, how many solutions will you have? No solution, right? We will discuss these cases in next exercises in details. This is just for the introduction, that if there are 2 lines, they can intersect or they can be parallel or they can be coincidental. And about number of solutions, we can say the points which are common to both the lines are solutions. So, for this scenario where these lines intersect, they can intersect at one point only, right, if they are different lines. Coincidental lines can intersect at, these will not be intersecting lines, right? Technically, these are overlapping lines. So, this is exactly one line only. These 2 lines are same, right? So, in this case, we will have one point which is common to both the lines. In this case, we will have no point which is common to both the lines, and in this case, we will have infinite points which are common to both the lines. Okay? Even if you do not want to get into solutions right now, you can say that there is one common point if you have got 2 different lines which are intersecting. no common point if you have got two parallel lines, and infinite points common to both the lines if these lines are coincident lines. Okay. Now these are certain points I wanted to bring to your attention. Now we need to talk about pair of linear equations in this chapter, right? So let us say one line is a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0 is another line. So combined these two lines are known as pair of linear equations. Okay, and I hope you know that this number that is with x, right, is known as coefficient of x, right. In this equation a1 is coefficient of x, and here coefficient of x is a2, right, and we can also write a1 square plus b1 square is not equal to 0, right. If this is a linear equation in two variables, then this condition has to be satisfied. Similarly, for this equation we have to write a2 square plus b2 square is not equal to 0, right. a1 is coefficient of x, b1 is coefficient of y in this equation, and c1 is known as constant, right. This is coefficient of y, this is coefficient of x. Okay.